Gemini helps. If you're using Gemini, it teams for you.
Hello, welcome to the recording. We're going to start in 4 minutes. The plan is I'm going to talk about system design for about 10-15 minutes, and then I'm going to let all the groups go work on their own system designs, and then after about 25 minutes of that, then Oz is going to sit down and review everyone's designs one by one as a big group together, which will be good. Okay, so you can sit back, grab a cup of coffee, and just, or you can skip ahead in the video for about 4 minutes, and I'll see you then. Thanks for coming. Okay.
Probably we find German class.
Totally. You did
Big
German?
subject.
Oh, nice. Okay, grab a seat, yeah? Hey everybody, I think I'm gonna start because I want to get you guys going. So I think the plan for today's session, just like last week, I yapped for a bit about design and structures and a bit of CAD and a bit of sketching. This week I'm gonna yap for a little bit about system design and talk about different system design elements that you might want to include in your robot. Hey everybody. So let me do a video. Yeah. So grab a seat, everyone.
I found out when during the meeting. Oh, you got No, but you from the I said, oh, you put something in my hand, you said that. I chose to do it. Why have you?
Can I just check? Have we got group 1 here? Ooh. Okay, that's fine. Don't worry. I'm gonna write this down. Group 1, group 2. Yeah. Group 3. We had those 2. Yeah. 4. Yep. 5. Yep. 6. 7. Oh, so sad. 7.
Well, that's better than.
And I think that's it. Yeah. Okay. So, no, it wasn't sad that only 2 of them showed up. It was sad that you put the hand up like this. Okay. So, system design. You're going to need to build a bot that picks up balls fundamentally. So you're going to be able to pick them and you're going to be able to move to them. So you're going to need motors. Yeah. That's definite. You're going to need at least 4, in my opinion. If you want to do 2, go for it. But I think 4 is like the standard for most bots.
You can go for more as well.
You can go for more as well, exactly. So when you have motors, you need to pick. You know, we've got a lot of motors in our cabinet already. You can pick from, but you could also see if you've got the budget to go buy some more, and you can look up whether they're brushed or brushless. You can look at whether they've got encoders or not. Lots of choice, but you want to make sure that you understand what the voltage level of these are, because the voltage level of motors is important for making our whole system work together as a complete unit. So the ones we have in that cupboard are 12 volts. A lot of them are 12 volts, but some are 6, some are 5, some are 24. Basically, this is a number that will matter when you start to wire electronics together. Another thing to look out for motors is your torque and your gear ratios. I know that our motors on the yellow bots, the small yellow motors on my green bot, which I've shown you guys last week, that has a 1:48 ratio. I think last year I bought ones that had about 1:32-ish. This is just a number. You can ask ChatGPT for help. It's about making sure that your gears are turning at the right torque and the right speed ratios to be able to move your bot, because your bot has weight and it's got to have enough momentum to spin all of the wheels in motion to move the bot physically. Otherwise, it will just kind of try and tick along, but it won't have enough power to do so. So that's another important factor.
We should also remember all these motors, even though you are wiring them up, you know your voltages, you also want to check out your motor drivers, which would be the circuits that are actually driving your motors and will be the abstraction layer between your motors, the way you control them, and the software and the rest of the electronics. And also do remember, you are on like a 4S cell or like a really small battery, especially with the size constraints this year. You do want to make sure you're not going too big with the motors, or not
very
too
important with
small
motors,
either.
especially this year, because you've got the special
Some
20
motors
by
last
20
year,
by 20 limit,
they
which is
weren't
a lot
able to
smaller than
move,
last year.
and PWM is usually
And especially when you put your
like,
wheels on
there
it,
is
it
no
adds another
sweet
bit
spot.
of
There's
distance.
either
So
too much
think
or
about whether
too
your
little,
motors are
depending
90
on what
degree
motor
motors,
driver
where it's
again
something like
you
this,
use. So
and you have
look
an
out
axle
for
like
these
this, or
things.
whether
Hope everyone's taking notes.
the full,
It is being recorded.
traditional motors like it was this. being recorded, it died. Okay, so
Next thing,
anyway,
as I said, is
size is very
drivers
important with
your
motors,
interface
especially
between
this
your
year,
motors
because you've got the special,
and
you've got the
your
20 by 20 by 20
control
limit, which
system,
is a lot
which is
smaller than
your,
last year.
microcontroller in our case.
And especially when you put your wheels on it, it
this
adds
is
another
where
bit
your
of
driver
distance.
sits in the
So
middle.
think about whether your motors are 90 degree
Your
motors,
drivers are
where
mainly
it's
to
something like
convert
this,
between logic levels. So
and then you
your
have an axle like this,
microcontroller,
or whether they're the full,
typically, what
you
we're
know,
using, we'll probably
traditional
use USB
motors like
framework,
this.
or you want to use Raspberry Pi. Both of those
Next thing, as I
will
said, is drivers. Drivers is your interface between your motors
So
and
5 volt
your
analog signal, which means
control
that
system, which is your, you know, microcontroller in our
you can
case.
send it a signal between 0 and 3.3 volts.
This is where your
and you can
drivers
send
sit
it
in the middle.
between 0 and 5 volts.
Your drivers are
Probably
mainly to
3.3
convert
mostly.
between logic levels. So your
What we need to be
microcontroller
careful
will
of is
do
that
typically
this
what we're
is-
using.
this is
We'll
a
probably use
control-
ESP
isn't
framework,
enough
or you want to
to
use
actually
Raspberry
power
Pi.
motors
Both of those are working at you know,
because
3.3 volts
remember
analog
we set up
signal,
here, the
so
voltage level
or
is
5 volts
12
analog
volts,
signal, which means
right?
that
So
you can send it a signal
think about
between
is
0
how do
and
we interface
3.3
it so
volts,
that when
and you
we
can send
are
it
powering
all
our,
between 0 and 5 volts, I think. Probably
we are
3.3
telling our
mostly.
microcontroller to output between 0 and
What we need to be
3.3
careful
volts
of is that
and output, and then
this
send
is
it to
this is
motor
a
which works
control
between
isn't
0 and
enough
12
to
volts.
actually power the motors directly.
How do we make it scale
Because
such that when we're
these,
at
remember we
0
set up
and
here,
0,
the
when we're
voltage
at
level is
3.3, it goes to
12 volts,
12,
right?
We're in the middle, it goes to the middle, so this is like, I don't
what
know,
we need to think about is how do we
1.8-ish.
interface it
This
so
is
that
like
when we are
6-ish.
powering our,
You know, it's about mapping between.
when we
this
are telling our
mapping action is
microcontroller
done
to output
by
between
our
0
motor
and
driver.
3.3
So
volts,
we want to pick a
and
motor
output,
driver that can handle
and then
the
send it to a
current
motor
from
which works
motors
between
because,
0 and 12 volts. How do we
there are
make
some
it
motors
scale
that are really
such that
thirsty
when
when
we're
it comes to
at,
current,
say, 0, it's 0, when
burn
we're
out
at
the motor
3.3, it
driver.
goes to 12,
So,
we're in the middle, it goes to the middle,
this
so
is
this
a
is like,
important factor to
I
consider.
don't know,
Your datasheet for your
1.8-ish,
motor
this is like
say
6-ish, so,
how much
you
current
know,
it
it's
draws
about a
typically,
mapping
and you
between,
can
and
use
this
that to do
mapping
that.
action is done by our
Once you
motor
decide how
driver.
many
So
voltages you're gonna
we want to
stimulate
pick a
the
motor
controller,
driver that can handle enough current
that will
for
tell
our
you about
motors,
kind of
because
what kind of requirements you need current-wise.
there are some motors that are really
Typically,
thirsty when it
the
comes
way
to
we are
current,
doing this
and
is,
it will
I'll tell
burn
you
out the
example
motor
for the
driver.
yellow box, which we're
So
in the yellow colour, that's big.
this is a important
The
factor
yellow
to
box
consider.
has
Your datasheet
these
for your
1 to
motor
48 12-volt
will
motors.
say
They have-
how much
it's got
current it
4 of
draws
them.
typically, and you can use that when
for
you
the
add
motor driver.
when
the
you
drive
decide
frame.
how many motors you're going to stick on each controller.
That's the 4 in
That will tell you
kind of
about
like
kind
a-
of what kind of requirements you need
it's like a
current-wise.
tank kind of thing.
Typically, the way we are doing this is, I'll tell you the example
And
for
it
the
has
yellow
two
bot.
motors
I'll
for
draw
the
it
lift.
in a
So
different
there's two
color, a
additional
bit
ones which sit
green.
on top, and
The
then
yellow
there's a
bot
lift that's like
has
this.
these 1 to
These guys
48
spin this
12 volt
way.
motors. They have,
Bring it
it's got
kind
4 of
like,
them
this in the section to
for
bring
the
it
motor
up.
driver.
So this
for the
is
drivetrain.
6 motors total.
So that's the 4 in
I will do
kind
this,
of like
I'll
a,
add, I'll do 2 lift.
you know, it's like a tank kind of
What
thing.
we
It's like
talked about with
1, 2,
drivers
3,
is
4, like a
on
car.
that bot is we
And
use
then it
a
has
driver
2
called
motors
the
for the lift. So there's 2 additional ones which sit at
It's
the
a very
top,
popular
and then there's a
driver.
lift that's like this.
It is
And then these guys spin this way.
It is very accessible.
Bring
You
it
can
kind of
unlock
like
very quickly.
this and this action to bring the lift up and down. So
9 a.m.
this has
like
6 motors total.
And its
I will
advantages
do this. I'll do
is the
add. I'll
cost,
do 2
the
lift.
ease of access. You can basically get
What
ChatGPT to
we
vibe
are
code
talking
this.
about with drivers is on that bot is we're using the driver
will
called the
have,
L289N. It's a
which
very
interface
popular
to your
driver.
microcontroller.
It is inexpensive.
and on the other side
It
it will
is
have 2
very accessible. You get it on Amazon very quickly.
connectors like this where you can have a
9
positive
9
and
a.m. my
negative
bad.
going into
9
one
8
motor,
It's
and you can have a positive and a
advantages
negative.
is the cost,
Going to
the
another
ease of
motor.
access. You can
So,
basically get ChatGPT to vibe code this.
It will also, this L289N is really good because
It
it's
will
got
have
3 ports at the top. One that
pins
does
which
12 volt
interface
in,
to your
one
microcontroller,
that's ground,
and
that's
on
5
the other
volt
side
out.
it will have 2
5 volt out. And this 5
connectors
volt
like
out
this
one
where you can
especially
have a
because we can
positive and a
power our
negative
microcontroller
going into one
directly
motor,
from the L2
and you can have a positive and a
going in, which is
negative
quite useful because it means we don't
going
have to
into
have
another
this
motor.
microcontroller
So
works at 5 volts. It means I can put the
it will
battery
also,
in here.
this L289N is really good
And
because
it
it's
will
got 3
automatically
ports at
do
the
the
top,
voltage
one that does
conversion to give
12
me
volt
enough
in,
voltage
one
for
that's
the
ground,
Raspberry Pi
and one that's
ESP,
5 volt out.
whatever I want to use.
Oops,
It means
5
with one
volt
that's
out.
component we have
And this
five.
5 volt out
So,
one especially because we can power
the next thing I
our
wanna talk about is
microcontroller
battery.
directly from the L2 98N, which is
I've had
quite
good
useful because it means you don't have to have this microcontroller works at 5 volts. It means I can put the battery in here, and it will automatically do the voltage conversion in here to give me enough voltage for the Raspberry Pi, for the ESP, whatever I want to use. It means there's one less component we have to buy. So next thing I want to talk about is battery. Now, I've had good experiences with NIMH, nickel manga hydronide, I think nickel metal hydride, yeah. Batteries in the AA format. So those are NIMH, yeah. So these are the green ones you might have seen on the Robot Football ones. They are like AA batteries, but they're rechargeable. I'm a big fan of these. They each have a normal voltage of 1.2 to 1.5 volts.
You can use lithium-ion ones as well.
So I put 10 of them in series to make 15 to 12 volts, and this 15 to 12 is perfect to just serve straight into my 12 volt in up here on the L298N. Other options are available. We last year used LiPo cells, and you can use lithium-ion ones as well. Lithium-ion. I am not so sure about these. These require a little bit more care and attention. They're better batteries for your weight ratio. They are a lot lighter, they are a lot smaller, but they need special care with charging to make sure you don't blow it up, because they are extremely flammable batteries, and if you overcharge them a little bit, they get a little bit too hot, becomes a real problem. They will puff up. You need to keep them in a charging bag overnight if you're going to charge it. But there's lots available, and they have different cell. They call it the cell notation. So there's 1S, 2S, 3S, and 4S and 5S. This means that there's a certain amount of cells within the battery that charge in parallel. And these have different voltages. So I think this one is, I think this is 11.8, right, Oz? I think this is 15 point something. This is like 18 point something. And these are nominal, which means you have your nominal, you have your charged,
your maximum charge, then you'll slowly go down,
and you have your discharged.
And this graph will vary in shape depending on
and this is your voltage level.
Some will go like this.
And what happens is, as your battery drains, it goes between these lines. And if we draw a battery voltage over current consumed graph, you'll see that you'll start at your maximum charge, then you'll slowly go down. And this graph will vary in shape depending on which battery you use. So some will go like this.
It's the average of this area,
and say this will be the V max for 1, this will be the V nominal,
your battery's gonna last
nominal, and this will be the V min.
It's very hard to make them not last,
for instance, and then same for this one, V max.
Probably gonna be fine.
The V nominal is about here,
3-4 minute match tops,
because it's
whatever batteries you put in,
the average of kind of it's like a it's the average of this area kind of thing. So it's you want to basically know that your batteries are gonna last on the day throughout the thing. It's very hard to make them not last, because whichever batteries you buy are probably gonna be fine. This is gonna be a 3-4 minute match tops. Whatever batteries you put in will probably last 3 to 4 minutes. If you're lucky, you could even use a capacitor for 3 to 4 minutes. It's not too hard. It's hard to get this wrong. But it's bad if you get it wrong, because it is explosive. This, especially lithium ions and lithium polymer batteries.
I do want to state something. There's obviously overcharging, but there's also something called over discharging as well, where it drops below a certain threshold, which is normal, right?
Minimum.
Minimum. And once you drop below the minimum voltage, it's also dangerous. That's when they usually puff up.
It's when you over discharge it. This is when you damage the cells within the battery itself, the lithium polymer. They can puff up. It also means in the future they don't retain as much charge. So last year we really fucked this up, and I bought a very expensive 24 lithium ion batteries. They are expensive. I think the 4S and the 5S are like £24. It's like £30.
The polymer.
Yeah, they are not cheap, and compared to these, I bought
XT60.
2 sets plus a
No, this one,
charger
sorry,
for
we'll use-
about
you need to buy a battery case 'cause it's double
40,
A's, right?
35-ish
Double A's,
pounds.
they have their little slots,
So,
put them in the
you know,
slots.
you can get probably for, this is
Buy
for
it.
2 sets.
This one will have a port
So
called XT60.
you'll probably get one for about £17 on
and it will also
Amazon.
have a cell charging port. And this charging
So
port you need to buy
you've got to think
a
about
balanced charger.
the trade-offs between the two. This one will use a port called
Okay.
XT60.
Next.
No, this one,
let's
sorry,
talk
will use,
about-
you need to buy a battery case because it's double A's, right? Double A's, they have their little slots, you put them in the slots.
It's quite important, but I think
You've got to buy it. This one will have a port called
we
XT60,
chat on a case by
and it
case.
will also have a cell charging port.
Next thing I think is really general
And
advice
this
is
charging
a
port, you need to
microcontroller.
buy what's called a balanced charger.
Now, the main thing to talk
Okay.
about with this is
Next,
where do you
let's
guys
talk
envision
about,
yourself doing all the processing, the heavy
You
processing.
might want to add more detail on the balance charger.
Obviously,
It's
you're
quite
going to have a
important.
camera.
It's quite
on this
important,
properly,
but I think
right?
that,
Because you need some way to see.
we chat that on a case by case thing. Do you
Does your
think?
camera?
Next thing I think is really general advice is a
Does your
microcontroller.
camera stream it to an onboard device like a Raspberry Pi?
Now,
which
the
is
main
connected
thing
off
to talk
with
about with
your
this
bot?
is where do
Or
you
do
guys
stream it
envision yourself
from
doing
the
all the
camera to
processing,
a laptop somewhere,
the heavy
do
processing?
heavy processing over there,
Because
do
obviously you're
the
going to have a camera on this
You'll have to
system,
do both.
probably, right? Because you need some way to see from your robot. Does your camera
microcontrollers and there are heavy ones.
does your camera
The light ones are things
stream
like
it to
Arduinos,
an onboard device like a Raspberry Pi, which is
things
carried
like
along
ESP
within your bot?
framework, ESP
Or do you
32,
stream it
which are very
from
popular
the
'cause
camera to a laptop
I love
somewhere,
them, but
do the
Wi-Fi.
heavy processing over there, and stream the
the
commands
heavy
back?
things are
You're allowed to do
Raspberry
both.
Pis and maybe
Trade-offs,
mini
they
PC.
have their own disadvantages and advantages,
So-
but there are light microcontrollers
I know,
and there are
you
heavy
guys know
ones.
about mini PCs, but you can buy these little
The light ones are
tiny,
things like
tiny,
Arduinos,
Intel Milk style
things like ESP for the framework,
i3,
ESP32, which are very
Celeron,
popular
like,
because I love them. They got Wi-Fi.
small PCs. They are
The heavy things
very
are
good
Raspberry
for
Pis.
your grandma to browse
Raspberry
for
Pis
PCs
and
on.
mini
But in my
PC.
opinion, they
So
power in the sense to be on physically.
I don't know how much you guys know about mini PCs, but you can buy these little tiny like Intel Milk style
Windows doesn't always run on
i3
Celeron.
Celeron like
this.
small
last
PCs.
year,
They are
didn't go that well.
very good for your grandma to browse the internet on, but in my opinion, they consume too
Yeah.
much power to make sense to be on
Your other
physically
problem
your
with a
robot.
mini PC
Your battery,
is that
you will burn
unlike
through
every
it,
other
in my
option on this
opinion.
list,
It
you
also
don't
requires you to know a lot
have
about Windows and how to set up Windows on these, and Windows
It's
doesn't always run
important
ideally
that you
on
have
such a
pin
small
outs
processor.
because
We did
you
do
need
this
some
last
way for
year.
your PC
This-
to talk to your
We did last year,
your
it
motion
didn't go that well in my
The AI processor was well. The only problem we had was the batteries again.
Yeah.
The current draw was just a bit too high.
Your other problem with a mini PC is that unlike every other option on this list, it doesn't have pinouts.
to the motor drivers.
It's important that you have pin outs because you need some way for your PC to talk to your subsystem, your motor controller, for instance, right?
If you had your laptop,
The Raspberry Pi has pins on it, ESP32 has pins on it.
there's no way
You can write Python, you can write C++ to send a voltage level on those pins. GPIO, general purpose input
There's no
output.
general
It basically
purpose
lets you send a voltage on pins and then connect the pins to the motor drivers, and that lets you
methods of doing this.
directly control it from the ESP or the Raspberry Pi. The mini PC doesn't have that. It's like your laptop, right? If you had your laptop, how do you connect it to
you
a
wanna
motor
do the
controller?
processing on the
There's
onboard?
no way here. I can plug a cable in here
Or do you
and
wanna
then
do
go
it,
on the other side to the motor controller.
remote?
There's no general purpose input
It's an
output. That's the
opinion-
problem
it's
with the
a
mini
decision
PC.
you as a team.
The
But
Raspberry
if you're
Pi and
gonna do
Arduino don't
processing
have that
on board,
problem,
you
which
need
is
to
why,
do
in my
every
opinion, they're the
microcontroller
preferred methods
on
of doing
the
this.
system as the robot is moving around. If you're going to do a remote,
You think about
heavy
streaming.
road lifting can be a laptop.
Do you want to do the processing on
And
the
then
on board,
your-
or do you want
this
to do
laptop can be
it
your own laptop,
remote?
You can have a nice GPU. You can have a
It's an
nice
opinion. It's a
AI
decision for
system
you
and
as a
a
team. Well, if you're going to do the processing on board, you need to be putting a heavy
server rack
microcontroller
with them, and
on your subsystem
it's
as the
allowed
robot is
to be
moving
possible.
around.
So you can
If you're going to do it remote, your heavy
regulation says
lifting can be a
go
laptop,
for it. As long as there's no remote control
and then
capability where you
your
are, as a human moving the robot.
this laptop can be your own laptop. You can run. You can have a nice GPU on it. You can have a nice AI system. I know Oz
This comes with
loves
some
his
problems
GPUs.
because
He could bring his
you have to
whole
think about
server rack with him,
putting
and
on the bot to be able
it's
to send
allowed within the
commands
Unibots
back
rules.
and
You
forth
can.
to send camera back.
There's
So,
regulations around
The
it.
regulation says
remote things
go for it.
are
As long as
things
there's
like,
no remote control capability where you are, as a human, moving the robot with
we
commands
have a
while the
buffer
play is
on our,
happening,
on our
it's open
Greenbot.
season for streaming.
So we have Shreyas's
This comes with its own problems because you have to think about what you're going to put on the bot to be able to send commands back and forth and to send camera back and forth. So some ideas of remote things are things like
WebSockets, if you're familiar, it's like SMTP.
you know, we have a mobile phone on our green bot. I'll draw it in green.
Video RTSP specifically.
So we have Shreyas's Galaxy A series phone, which has an Android app on it, which lets you do this thing called RTSP streaming. And RTSP stands for real-time streaming protocol. It's like HTTP. It's like WebSockets, if you're familiar. It's like SMTP for email. It's a protocol that we use to send. To stream video, RTSP specifically, and the phone can stream to the laptop, which is Shreyas's laptop, and then I also have a ESP32 on board, which connects to the motor controller,
on the bot.
If I remember correctly,
controller, and then this guy is using this thing called, UDP packets. You can use UDP, you can use HTTP, you can use whatever you feel is right. But this is what I have for Greenbot. Other architectures I've seen in the past include using a mini PC on the bot, connected to an ESP32 on the bot,
Raspberry Pis are great because you can
connected to a motor controller, connected to the motors. And then the mini PC has a camera connected to it, and in Bash Bosh, it's done everything within the bot.
By itself do all the processing, or it has
you know, there are lots of different architectures for picking this. You could pick a mini PC, or you could pick a Pi. Raspberry Pis are great because you can put a camera straight into it. You can put the motor controller straight into it, and you can put the motor controller straight into the motors. But the problem you have then is that this Pi then has to, by itself, do all the processing, or it has to stream it to the laptop and back. So, you know, it's a decision for you guys as a team to think, do we want to do it on board, do we want to do the heavy processing remote, and if we're going to do it on board, what kind of subsystems do we need on board to make it work? If we're going to do it remote, then whose laptop are we going to test it with, and what kind of things are we going to use to stream the data from place to place?
If you wanted to add
I think I'm reaching the end. We've got camera. You can use a USB camera, or you can, for the Raspberry Pi, it has a specific port for a Raspberry Pi style camera, which you can use as well. But you can use a hat as well. We don't have any of these. We use USB cameras all the time. If you wanted to add special things like a LiDAR sensor, a time of flight sensor, these are things we can explore. I've never seen a team use them. If you're able to use it correctly, you might do really, really well. Lastly, servos. I think servos is...
I do want to add in a safety consideration.
Yeah, hit me.
With GPIO, again, it's really important you directly go to an MD, always a motor driver. GPIO pins, by design, they are only
for little flaps, little things that go back and forth,
they only work at a certain current level, and these are little small traces on the PCB that can burn up easily. We've burned the Pi before, have we not?
We've burned a Pi before, so don't burn a Pi. The Pi was £70, so don't burn a Pi.
The Raspberry Pi 5.
Really simple. Other options for your battery before I just finish off?
If you want to use servos for little flaps, little things that go back and forth, little doors that open and close, you can basically plug them into any general purpose microcontroller. So all of this here is a bunch of servos and one ESP32, and it's just off my laptop on 5-volt USB cable. Really simple. Other options for your battery before I just finish off. Some people can just buy an off-shelf power bank.
The last two bits, if you
it's an option. If you get motors that are 5-volt-ish,
so you don't,
2 or 4-volt-ish, 3-volt-ish.
How do you bring a voltage level from? What kind of device do you put?
You can definitely just buy an off-the-shelf power bank because they will give you 5.
Okay, so
and it will give you a lot less trouble because it's all USB.
And there's a thing called a boost converter.
If you need to, the last two bits, if you, who's in studies electrical engineering?
Yeah.
Okay, so for those of you who don't, how do you bring a voltage level from, what kind of device do you put? So if you want a high voltage to a low one.
Down to a low voltage. This lets you bring
so
low voltage signal.
Here, there's this thing called a buck converter. and a thing called a boost converter,
So you can do high
and
to
a thing
low,
called a buck boost
or low
converter,
to
which
high.
is the two of them combined.
low to
Yeah?
These
This
are
is,
probably the most useful things you'll
Lets you bring in
We
a
need to
lower voltage
cobble
signal
the system together very,
and
very quickly.
bring it
This will
a
let
high
you
voltage
work
signal and bring it
things
down
that
to a
should
low
work
voltage.
together and make
This
them work
lets you bring
together.
a low voltage signal and bring it up to a high voltage, and this lets you do both. So you can do high to low or low to high. Low to high.
So
These op amps, by the way.
These are probably the most useful things you will find when you need to cobble a system together very, very quickly. This will let you work things that shouldn't work together and make them work together.
But please do keep in mind, it's not free energy. It use vehicles like your power
Yeah.
and your
All I
current
wanted to chat
So-
about.
ranges all the time.
Once you got any other comments?
Current times voltage equals power, always. Now let's say you have a higher voltage, lower current, you can turn this into a lower voltage, higher current. And it goes vice versa. There is no, and do pick your wire gauges accordingly as
Yeah.
well. Just saying.
Okay, I think that's all I wanted to chat about.
It works.
Oz, you got any other comments? Last comments?
Not really, it's just like
just,
it is
quickly
quite
you get
janky, it is
prototype,
very
the quicker
fucking
you realise
janky.
things
Do definitely
The quicker you realise things break, the
like
quicker you
spend a lot of
fix it.
time
You
on
want to be able to be
like picking out the most pedantic parts, down to the wires, down to the buck boost, down to the right parts.
Yeah.
It's just
Pick stuff, test it. If it works, it works. If it doesn't, swap it.
Advice written in blood.
Stuff it doesn't realise it doesn't work.
And just the quicker you get to a
One or two
prototype, the
pieces
quicker you can
January
realize
should
things
be like-
break. And
There's no
the quicker
reason
you
why we
realize
can't
things
be
break, the
actually
quicker you can learn how to
You wanna
fix
break
it.
it.
You want to be able to be in I want first week of January. I want people
You guys want to be in
CAD,
the second week of
CAD to be
January
done.
with
And
the
people
bot
have done
and see
CAD
it
over
moves,
Christmas, so they
right?
come back
Come
in
on,
January. They
right?
print.
There is no
They
reason why
print
we
some
can't do
stuff.
it.
They
We
print
can
stuff.
be
They realize it
ambitious,
works.
push
Print
for
stuff.
it.
It doesn't realize it doesn't work. And
Let's just get the
then
designs done.
1 or 2 weeks into
iteration of
January,
thinking
we should
done
be
now,
like.
and then we hit January,
There's
we
no
build.
reason why we can't be actually have finished an electrical subsystem and someone has programmed the code to move across the floor. And that's the fun part, right? You guys want to be in the second week of January with the bot and see it move, right? Come on, right? There is no reason why we can't do it, and we can be ambitious and we can push for it. Let's just get the designs done and the iteration and the thinking done now, and then we hit January, we build.
I do have a bit more advice. Usually, the way these regulations go, the way scoring works on Unibots, again, from like just in a hindsight sort of manner, you do definitely want to look at the regulations, the rules, and how the game will work out, and design your bot according to that. So you can be very ambitious, you can be very like highly technical, but as long as like it's not like adhering to the not just the
Right,
rules
the
as
plan I
in
have
regulations
now
wise,
is until
but
probably 3 o'clock.
strategically when it
You guys
comes to
can
other
chat
bots, like
amongst
a
yourselves,
bot
think
last year
about
could
designs,
sweep
maybe get
over
Sketchpad out,
all
maybe
of
get Apple
the
Pencil
all of
out
the
of the
balls
bag,
without like
and,
dumb
just
logic,
paper
and
here.
it ended up getting all the
Draw
points. So you
what
want
you
to think
think a
about
diagram would
these
look
things
like.
as well. Like, of course,
And
if you
then
want to win,
I will be gone,
that
but
is.
Oz will be here
If you
to
don't,
do your
then
designs. We can start at
awesome.
3:05.
Cool, right.